please confirm if the PPT is visible to all of you and also my voice is clear.
Yes, sir. Both are.
Sir, it is visible.
Yes, sir.
Yes, sir. Visible.
Yes, sir.
Thank you.
Lights
Thank
are
you.
visible, sir.
Thank you.
Audible also.
Thank you. So today topic is lawful interception. So lawful interception is interception of voice call or interception of data or interception of certain metadata like calling number, call number, time of calling, etc. Comes under the lawful interception, and it is done after approval of certain authority. For example, in state government, generally approval comes from joint secretary level officer. Similar is the case of central agencies. So today I'll be talking about different standards of these lawful interception related to 5G and how the architecture itself is there for lawful interceptions. So there are three related standards of 3GPP. The first one is 33.126. So this is the standard which gives requirement of lawful interception. And then the next document 33.127 gives the architecture and different functions. And finally, protocols and procedures are in 33.128. Our focus today will be mainly on this, and of course, this will get covered automatically. So we'll not be going deep into protocols and procedures that can always be read in case someone need to implement. Okay, so to understand lawful interception related architecture and activities, we need to understand various terminologies which are used. So I'll start with different terminologies or definitions. So the first one is target. So when we say target, what we mean is uh, the subscriber or the customer who is to be intercepted. If police want to intercept a call of a person, so that is a target. So the subscriber number or mobile number which is to be intercepted is called target in terms of lawful interception. The next term is CC. So CC stands for call content. Call content. So that means be it a voice call. So if voice call is getting recorded, so that is a CC. If the target is trying to access internet or YouTube, so the video or audio in that is a CC or call content. The next terminology is IRI. IRI stands for intercept related information. So when we say intercept related information, that means we are talking about metadata. And this metadata can be like what is the date and time of calling, what was the calling number, what was the call number, when call got disconnected, or what was the location of the target. These are IRI information or intercept related information. Then there is something called IRI event. So various event inside the 5G network is called IRI event. I can give one example. When a mobile phone gets registered onto the network, so registration of a mobile number is one of the IRI event. And as we know that in 5G, when a data session is created, basically it's called PDU session. So creation of a PDU session is also a IRI event. So such events are called IRI event because that will give some information to LI agencies. The next terminology is about LI component, lawful interception component. So those network function which are handling lawful interception related activities are called LI component of the architecture. And then we have LIID, Lawful Interception ID. So whenever a target is provisioned for interception, a ID is created for that particular interception. So that is called LIID, and that is used to track all the activities being carried out for that purpose. So LIID, every interception provisioning is done using an LIID. And then we have LI system. So if all the LI components are put together into overall architecture, so we call it LI system. There are some more definitions. Those are the word used is provisioning. So suppose whenever a target is to be configured into 5G system for lawful interception, so many network functions are to be configured. So term used is provisioning. So we provision different relevant network function to start interception. So that is called provisioning. And then there is something called triggering. So some of the network function cannot be provisioned directly. So they are actually triggered by some other network functions. So that aspect is called triggering, when a point of interception or a network function which gives either IRI or CC cannot be directly provisioned. So only a trigger function is provisioned, and that trigger function triggers the actual point of interception to start. So that's called triggering. And then a terminology in the standards is of warrant. So warrant is nothing but a approval letter given by agencies like police or CBI or NIA to telecom service provider or to Department of Telecom for a starting interception on some numbers. So that is called standard in the specification document, called warrant in the specification document. Now there is a terminology called XCC. So we had talked about CC. CC is call content, and this terminology is sort of plural in the sense of, and when we say XCC, we are talking about specific call content of a number at that particular time. So XCC is the actual data of call content which gets transferred to uh, enforcement agencies. Similarly, IRI, so actual content of intercept related information is called XIRI. And then we have CSP. CSP is communication service provider. In India, we call it telecom service provider, TSP. So it's mobile provider like Jio and Airtel. So these are different terminologies which we have to remember before we go into the architecture. Uh, in the shared slide, I have given detail which I explained earlier. So you can read anytime. So I'm skipping these because I have discussed this. Okay, so let's look at very, very high level lawful interception architecture in 5G. Just look at this picture. So these are different network function related to interception in a 5G architecture. So 5G architecture, which we have studied so far, we had left these network functions. These are also part of a 5G network used for interception related activities. So I'll just name these network function for you, and then we will discuss these into detail. So at the lower side, what you see is the agency itself. So there will be many agency, about 10 agencies, about 8 to 10 agencies are there in India. For example, CBI, NIA, ED, and so many. So, and there are state agencies. So 8 to 10 agency in every state you can find it out. So these are called LEA or law enforcement agencies. And in the LEA domain, generally they have a equipment called LEMF, Law Enforcement Monitoring Facility, which actually uh, captures those IRI and CC which I talked about. Then in the network side, so these are kind of a LEA domain, and upper portion is the communication service provider domain. So what do you have is something called admin function. Admin function, which is divided into two part. One is the LI control function, another is the provisioning function. So we talked about provisioning. And then inside the network, you have point of interception, where interception takes place. So although we are calling it point of interception, but this may be UPF. UPF is one of the point of interception because you can monitor or capture or intercept data at UPF. AMF can be also a point of interception because at AMF we know the location of the target, or maybe when he registered, when he disconnected, all those information will be there with AMF. So AMF is also a point of interception. So point of interception is nothing but a particular network function which can provide some information to agencies. Now, I had talked about that some of the point of interception cannot be provisioned directly. So there is a triggering function. So triggering function is provisioned and then it triggers the POI whenever interception activities are to be started. Then here we have something called MDF, mediation and delivery function. So MDF function is to capture the CC and XCC and XIRI from the network POI, convert into a format which LE understand and transfer to their LEMF equipment. Similar to a network function NRF, network repository function, which actually can discover any other network function, there is a network function called SIRF, System Information Retrieval Function. This is also a repository of addresses of all these network element related to lawful interception. So any question in this architecture or shall I proceed? You can say yes or no or proceed.
Proceed, sir.
Yes, sir.
Okay. So let's look at role of each of these LI entity or network function here. So starting with LEA. So LEA is here. So what LEA does is it submits the warrant. In our country, we call it interception order or approval letter of interception. In some other country, basically, it may be a document coming from judiciary. So that becomes a legal document. In our country, a joint secretary level officer in the government approves interception for those LEAs, and LEAs are able to submit it to Department of Telecom or to the telecom service providers to start the interception. The next network function we have is the admin function. So admin function, as I told, that is for administrative and management function of LI capability. So for TSPs, this is the element which allow them to manage the interception related activity onto the network. It has got two entity. As I said, one is called LICF, another is called LIPF. So the control part is here and provisioning function is here. So LIPF is provisioning function. So it provisions all other network function for interception. Generally, in a network, you will have one LICF, but there can be multiple LIPF. This can be multiple. So one LICF control function is one, but provisioning function can be more than one also. Generally, it will be one, but technically it can have more than one. Generally, what will happen if you have a geographically distributed network, so you may like to have more than one instances of LIPF. There is an interface between LIPF and LICF that is called LI underscore ADMF. So this interface I'm talking about. Now let's look at LICF functions, control function functions. So basically the entire life cycle of a warrant. So warrant is coming from LEA. So the whole life cycle of the warrant is managed at this control function. That means whenever we get order for interception, so start date and end date both will be there. That interception to be started, and there may be because approval will come for 1 month interception or 2 month interception. So that means in the network you have to start interception at some point, and also you have to stop interception at some point. You need to provision it, you need to transfer it to LEA. So all these uh, control on all these aspects are by LICF. All the sensitive data will be with LICF only, because interception is a sensitive matter. So which number is being intercepted, for what time, all these informations are there with LICF. Other network functions are not storing such information. They are not storing such information. So all the sensitive information will be the control function, LI control function only. And it has got full kind of a control on all the decisions. And it has interface with LEA. So what it does is, like, as I said, that provisioning will be done by LIPF, but LIPF would require certain information. So LIPF, as I said, cannot store sensitive information. So all sensitive information is here. So it is LICF which drives the required information. For example, LEA provides only mobile number for interception, mobile number for interception. But as we know that inside the network, I require MC. So LICF can drive MC from mobile number by talking to UDM, Unified Data Management. Uh, so so the full control is with LICF. Uh, but query and response with any network function will be done by LIPF. So it is a kind of a proxy for LICF. The only thing that it will not store any data. So this is about LICF. Then about provisioning function, which provisions other point of interception and other network element for LI. So which network function need to be provisioned whenever there is a case of starting interception of a target? So of course, point of interception we have to provision, and point of interception can be AMF, SMF, or UPF. Then triggering function, and also the mediation function. So these are the three main entities which need to be provisioned. So it is LIPF which provision and deprovision activity is done. And of course, it is being done on control of LICF. It's a proxy of LICF. And this will not store any data, as we had discussed. So So when it has to provision all the network function, so there will be certain POI which will be directly provisioned, and there will be certain POI which cannot be provisioned. So corresponding trigger function is provisioned for that purpose. So this is the way a particular network function can be provisioned by LIPF. Okay, so now let's talk about SIRF. So SIRF is equivalent to NRF, network repository functions. That means whenever any other network function, be it LICF, LIPF, triggering function are installed or any changes made, they have to register into SIRF, System Information Retrieval Function, similar to NRF. And then the LIPF, suppose LIPF has to provision a network function. So it discovers by querying to SIRF and then it provisions. So SIRF is having all the system information of the network function, and LIPF gather that information and pass it on to LICF because it doesn't store any information with it. Now the question is, what is point of interception? What is point of interception? So in this picture, you can see here, this is point of interception. This is point of interception where actual interception takes place. This can be AMF, SMF, UPF, or even if the SMS service is there, then SMS function. So basically, when we say point of interception, it is able to detect a target communications. What does it mean? That suppose a target or number has been provisioned for interception. So whenever there is a call, so this POI will be able to detect that a call has started and it will start monitoring and providing information to uh, those XCC and XIRI information will be produced. So what it can do, what POI can do, it can drive IRI, intercept related information, calling number, call number, when call started, when call ended, such kind of information. It can also drive the call content itself. Suppose it's a voice call. So recording of the voice call itself, it can capture. And then once these are captured, so this POI is having XIRI and XCC call content. So these are to be given to MDF, mediation function. So it will deliver to mediation function. So there are two kind of mediation function, although in this picture we are showing only one. So one is the MDF2, which is for IRI, and one is MDF3, which is for CC. So this point of interception will transfer it to MDF. So as I said, that point of interception is nothing but the normal uh, network function in 5G, for example, AMF. So generally the capability of point of interception will be built inside this itself. So this is also kind of a either POI, we call it point of interception. So this will also act as a POI. So all the features related to POI will be present, or I can have a separate one POI, but it will be connected here. So both possibilities exist. So whenever there is a warrant, from LEA, can you think how many network function we have to provision? So whenever LEA gives a warrant, mobile number to intercept, maybe I need to provision AMF for IRI, maybe SMF for IRI, maybe UPF for call content, maybe SMS function for intercepting the SMS. So whenever there is a warrant, there are multiple network functions involved for interception. So there will be multiple point of interception for a single warrant execution. So this is about POI. Now there are two types of POIs. One we call it directly provisioned POI. So this, if you see this picture, this can be directly provisioned by LIPF. This can be directly provisioned by LIPF. For example, this is a case of AMF. AMF can be directly provisioned by LICF for interception. There are certain POI which cannot be provisioned directly like this. So this may be triggered from other network function called TF for triggering function. So in this case, this will be provisioned. This will be provisioned. Why? Because this network function is capable of detecting a communications. So it can detect. And once it is able to detect, it triggers the actual POI to start capturing either IRI or CC. So example which I can give here is you have suppose SMF. Along with SMF, I may have a triggering function, and UPF is a network function which can give you CC but need not to be provisioned directly. So this triggering function in SMF can actually trigger whenever there is an interception required. And why? Because all the PDU session creation is done by SMF. So SMF knows better that when a PDU session is created, when a PDU session has to be modified or turned down. So it is in a better control. So SMF is a triggering function for UPF. So that's an example of provisioning the POI which cannot be provisioned directly, but they have a triggering function. So triggering function need to be provisioned. So the capability of triggering function is that it can detect a communication. And once it is able to detect, it will suppose this triggering function is SMF and it has detected a communications of the target, then it will kind of a trigger the POI. When I said trigger means it will send all necessary rules, what is to be done, etc. And also how it is to be forwarded to MDF to this point of interception. So basically this point of interception is kind of being controlled by a triggering function for interception related activities. Actual provisioning has been done in this, and this is taking care of all the provisioning needs. Many a times the triggering function need to talk to other network elements, particularly for having the correlation. For example, suppose uh, this is having say MC number, but it has to have some more information. So it may talk to UDM and get other related information of this, other subscription detail of this MC. So all those correlation information for that purpose, triggering function may connect to other POIs. So there can be two type of triggering functions. Those can be like, suppose you have TF, so two type of TF. So one TF handling IRI, so intercept related information. So we call it IRI TF, and we can also call CCTF. In my example, when I was saying that point of interception is UPF, so UPF will generally provide call content. In that case, this TF I can say as a CCTF. call content triggering function. Similarly, there can be a TF which is triggering a point of interception for IRI. Okay. In a similar way, the point of interception can also be of two types. One is IRI type, another is CC type. So IRI type or CC type. If it is IRI, then it connects to MDF2. If it is CC type, then it connects to MDF3, type 3. And such POI can be directly provisioned or maybe triggered. So those are things. Now let's look at mediation function, MDF, mediation and delivery function. So as we had discussed that MDF on one side connects to the LEA equipment called LEMF for transferring call content and also the intercept related information. On other side, it connects to POIs, point of interception. So it get a specific IRI and a specific CC. And it also gets connected to LIPA for provisioning purpose. So we were discussing that MDF2 is for IRI and MDF3 is for call content. And they are also connected to each other on LI MDF interface. So they also need to actually exchange information between MDF2 and MDF3. For that purpose, this interface is there. Now, LEMF is equipment which is in the LEA domain. So once they receive IRI and CC, the LEMF role is to understand that information and also analyze that information and provide whatever insights are required by those agencies. Okay, now let's look at the full architecture now. So we have seen all the network function related to LI. So how it uh, look like once we have the full network. So this is the LI architecture of 5G core along with all other network function. And this is standalone architecture, SA architecture. So SA 5G. So as you recall that in a 5G network, I have AMF, SMF, policy control function, network slice selection function, equipment register, unified data management, SMS function. There can be location related function, NRF, user plane function. And then onto the access side, I can have a new radio. So that is 5G RAN, or I can have a LT radio, 4G RAN, or I can have a non-3GPP access through N3IWF. And so your target can be using any of these networks. So for all these, interception would be possible. So what we discussed so far is like we talked about LEMF, we talked about mediation and delivery function, we talked about LEA, we talked about LI control function, LI provisioning function, we talked about SIRF similar to NRF. And then we also talked about different POI. For example, if you look at AMF can provides the start of a call, end of a call, location. So this is an IRI POI. SMF also provides like the when PDU session started, when PDU session stopped. So this is also a IRI POI. UDM also has subscription data, some metadata. So IRI POI and SMS function is also an IRI POI. Now the UPF provides you the call content. So it is a CCPOI and it can also provide some more metadata. So it is also a IRI POI. Okay. So this is the complete architecture of 5G along with the LI component. Maybe I'll stop here for any questions. Do you have any question so far? Shall I proceed?
Please, sir.
Excuse me, sir.
Yeah.
So if this lawful interception is like on demand all the time, the system should have all these provisions, because we are not sure ki when it is required, and though only limited agencies can do it, this should be ready at the back end. Am I correct?
Yeah. So if you look at the license conditions which we have for our telecom service provider, so whenever they go for a new telecom setup, for example, when they wanted to do 5G, so they are required to showcase this LI architecture even before they can launch the service. So that's a mandatory requirement because there can be terrorist activity, there can be anti-national activity once a network is live. So unless you have capability for interception, that will be a problem for our enforcement agency. So it is mandatory for operators to have these LI equipment, but these are not required for lab environment or private 5G environment where no public service is being offered. So it is only for the public network of Airtel, Jio, Voda, BSNL, and so on.
Okay, sir.
Right. Okay. In this picture, what you see is like the blue colored lines, no, the darker solid line is for transferring the call content. The thinner blue line is for transferring IRI, intercept related information. So all those places you can see these are IRI. Then dot line you see is the control plane, for example, provisioning, etc. So all these dots line are. And the black color lines are for network. So for example, this is for user plane data. This is for actual data, 5G data. And the smaller one, the thinner black line is for control plane data. And so these are all the nomenclature or the identification thing which you can understand. This is SA architecture. So what about NSA architecture? So NSA architect, this is the NSA architecture. In NSA architecture, I have 4G core, 4G core, or we call it evolved packet core or EPC. So in a similar way as we have SA architecture, I have all the LI related network function, and within the EPC, there will be some IRI POI and some CC In this picture, it is not shown. For example, MME is one of the POI for IRI. Then as the user data flows through serving gateway, so serving gateway is a CC So here we have shown just like a IRI POI and CC POI. So there can be many IRI and CC POI, point of interception inside the 4G core. And rest of the architecture and legends are same as of the previous one. Okay, now let's look at interface. So what we have, so if you recall, in a summarized way, you had LEA domain, right? And then you had some sort of uh, mediation related domain and also the provisioning admin domain. And then you had POIs or network function. So let's look at different interfaces around all these and their nomenclature. So from LEA to the admin, the interface which we saw is called HI1, HI1 interface. And then we had a LEMF, which is the equipment towards agency. So they generally receive the call content and the intercept related information. So HI2 is the IRI content, HI3 is CC content, and HI4 is for management and control kind of aspect. So this side we have all the interfaces starting with HI. So these are HI interface. Onto the network side, so there are three interface. We call it X1, X2, and X3. So let's look at X1. X1 is provisioning one. That means from LIPF provisioning function to all the POI and triggering functions and MDF function. These are X1 interface. So X1 is going to MDF and also to the network functions, or we call it POI. X2 is like when those POI is delivering the call content or IRI. So X2 is IRI and X3 is CC. So we have X interfaces. So H1 interface and then X. H1 1 to 4, 1, 2, 3, 4, and X1, X2, and X3. These interfaces are there in the entire architecture. Let's go slightly deep into it. So if you look at the same architecture which we saw, so first we talked about H1 interface. So H11 is here where warrant is transferred. H12 is here, which is for IRI, if you recall. H13 is for CC, transferring CC. And then H14 is for control and management. So these are H1 interface. Now, now we talked about X1 interface. X1 I said is for provisioning. So it will be from LIPF. So just see from LIPF to MDF, from LIPF to triggering function, LIPF to again POI. So these are all X1 interfaces for provisioning purpose, and in some cases management purpose, because triggered POIs are only managed, not provisioned. So these are X1 interfaces. X2 interface, we understood that when a POI gives the call content or IRI. So this is the X2 when IRI is given to MDF, and this is the X3 when CC is given to MDF3. So these are all interfaces of lawful interception architecture. Okay. This is very interesting and important slide, that how a provisioning is done onto the network. So we'll see through a small animation. So this picture shows the network functions. So here are network functions. They can be AMF, SMF, etc. Then you have an admin function, which has information to provision and connect to the LEA. And then an RF equivalent, SIRF. So how provisioning is done? So first thing which happens is that the LEA provides a approval letter or warrant, and it goes to admin function, particularly LICF or the control function. Now LICF has received say mobile number, but to provision POIs you need say IMSI. We call it SUPI, subscription permanent identifier. This is a kind of a IMSI. So LICF is driving this information from say UDM, and then it is passing on to LIPF for provisioning. So provisioning request is going from LICF to LIPF. Now LIPF has to know that which all POIs are concerned. So it has to discover through SIRF. So it will talk to SIRF and get the information. So basically SIRF have address of all the POIs or all the NF. So it is able to fetch that information. And then once it has information, it has to provision. So it is provisioning what? So as we discussed that it provisions POI, it provisions triggering functions, and also it provisions MDF. So all these aspects are being provisioned in step 4 here. And then it is kind of a ready. Once this provisioning is complete, it is ready. in the sense that now whenever there is a call or data being initiated by the target, the system will be able to monitor that or intercept that. So how that happens? So how interception process takes place? So the first thing, so just look at this diagram. So I have all those POIs here, right? And here, like here, I have a UPF, here I have SMF, AMF, MDF, and agencies are here. This is your tower. So suppose a target, this fellow is being intercepted. We have already provisioned. So whenever he tries to make a call onto 5G network, the first thing which happens is the creation of a PDU session. So basically it's a PDU session creation request goes to AMF, and AMF pass this on to SMF, as we know, session management function. Now, along with the session management functions, there is a point of interception, IRI POI, and there is also a triggering function, because now SMF is the first element where it knows that now a call will start. So at that point, this POI will just check it whether the call which is coming is to be intercepted or not, right? So what it will do, then it will uh, kind of, the provisioning has already been done. So it will trigger, it has to trigger. So one is that IRI POI function will start. That means it will start capturing start of PDU session, etc. Parallelly, it will trigger, uh, parallelly, it will ask UPF to create a session and CCPOI inside UPF to start monitoring the call content. So triggering function is coming here. So now UPF is triggered. So it's a parallel one. Whenever session is being installed, created, a triggering function has given a command to UPF to start capturing the voice or data, whatever it may be. And parallelly, whatever is being captured will be passed on to LEA through MDF. Through MDF. So MDF on X3 interface, it gets CC and POI, IRI, and then it pass it on HI interface. So call content and also whatever is required for that purpose. So this is how interception takes place. So many a times we get a queries that in case of a 5G, how interception will happen. So since all the call passes through UPF, so UPF is a point of interception where we can get call content, and all other network function we get certain metadata, yeah, intercept related information. Any question at this point? Any question or query at this point? Shall I proceed?
Yes, sir.
Yes, sir.
Thank you. Thank you. Okay. This may not be very interesting for you, but this is very important function of any network. And maybe like yesterday, we had a session about rogue BTSs. So that was illegal setup to intercept something, and this one is the legal setup. So as we talked about that 5G network can be virtualized. So even the LI system can be deployed on a virtualized environment. So you'll have a virtual POI, virtual MDF. And in this case, since we have to make a virtualized deployment, so I need a MANO for LI, management and orchestration. So what I'm trying to say that all these network functions related to LI can also be deployed on cloud, maybe on a VM environment, maybe on a container environment, or maybe on a bare metal. So all possibilities are applicable even for LI architecture. So slightly more detail in respect of different network functions. So let's talk about access and mobility function. Certain new things will come to picture. So what happens is that so generally what will happen when LEA gives warrant, it goes to admin function and LICF, and LICF ask LIPF for provisioning. So now this LIPF will provision AMF also as IRI, because AMF can provide certain information like registration detail and also the location detail. So that's why AMF need to be provisioned. And then once it is provisioned and call has started, it will connect to MDF2 and provide those call content, that is XIRI. And from MDF, it will go to the agencies. So this is the step followed for AMF. If AMF is being provisioned for interception. So while provisioning is done, what information AMF will uh, need to be provided? So there can be any of these information, So generally agencies will give you mobile number. So that we call it MSISDN, or we also call it GPSI. So it's nothing but mobile number. But sometime you will not get this. You may get only the EMI number. For example, if your mobile device has been lost and you have raised a complaint, so it is possible to intercept based on mobile ID, permanent equipment ID. You might have heard about EMI. So based on EMI also we can trace or do, because many a times what happens, these uh, terrorist activities, they keep changing the number. They keep changing the number, but they keep the same mobile handset. So in that case, if I provision using EMI number, we'll be able to intercept the call even if they are changing the mobile. And other is based on SUPI, subscription permanent identifier, or IMSI. So one of the SUPI is IMSI in case of a 5G. So these are basically parameters which need to be provided to AMF for interception. Any one of it, either SUPI, PI, or GPSI. In fact, once you know one of the parameter, other parameters are already there in the 5G network. If required, that can be uh, taken care of internally. So I talked about IRI event during the definition. So what are the IRI event which AMF will have? So those are like when a mobile registered, when the mobile deregistered, when it did the location update, when interception started, what are the unsuccessful communication attempt? Not every time he makes a call, he attempts, but call do not go. So all these events are called IRI event, and these are also captured. And what is the output? That is XIRI. XIRI will have what parameter? So that can have the target identity. So LIID, as we said, right? So LIID will help find which number and all. Timestamp would be the next parameter. So since we are doing AMF, so the location information, either cell ID or tracking area, and other correlation information like IMSI. Any question? Somebody want to ask any question? Okay. Okay. Similar is the case. Madhukar, if you can mute. Thank you. Do you have any question? Okay. Similar is the case for SMF or UPF. So when SMF and UPF has to be provisioned. So as we know that once our admin function receives warrant, so LICF finds out correlation information, pass it on to LIPF. LIPF provisions. In this case, it is provisioning SMF, right? So SMF provisioning means SMF is an IRI. So this IRI will be provisioned. It is also a CCTF, call content triggering function for UPF, because UPF is not being directly provisioned. It can only be managed on X1 interface. So provisioning is done to CCTF. So whenever there is a call happening, as we saw in the process flow, this SMF triggers UPF in addition to direction of starting a PDU session. It also triggers for interception. So this SMF and UPF are combinedly working because SMF is also triggering function for UPF. So this is how it is done at SMF level. So what are the IRI event for SMF? The PDU session establishment, modification, release, and when interception started on a established PDU session. So in this case, what parameters are intercepted? Target identity, what is the ID of the target, timestamp, correlation information, session related information, and also the location information. There can also be an IP address kind of. As IRI, you will also have IP address because IP address is allocated by SMF in 5G architecture. Similar is the case of SMS function. Suppose you want to intercept SMS. So it is exactly similar manner. The LIPF will provision the SMS function. So SMF, you have metadata and also the SMS itself, SMS payload, you can say. Both are categorized as IRI. Both are categorized, although it is a kind of a call content, but SMS entire metadata plus SMS itself is categorized as IRI, intercept related information. It is not categorized as CC. That's the difference we have. Somebody may ask you that whether SMS is an IRI or a CC. So in fact, it is IRI. What are the targets? So target can be SUPI, PEI or GPSI as, and what is the event? The SMS itself is an event, and parameters are like these are common thing: target identity, timestamp, location, but SMS direction, whether it was incoming SMS or outgoing SMS, and the SMS itself, SMS payload. These are parameters which are part of XIRI and passed on to agencies. And the lastly, we have SIRF, which is nothing but equivalent to network repository function. And interaction with SIRF is done by LIPF, but this information it's passed on to LICF. So it's a repository function. So whenever a network function related registers, come into picture, it has to register. Whenever there is a change, it has to update. Whenever it is we make it down, so deregistration. So all those aspects are information is available with SIRF. That's why we use it for discovery of different POI, etc. So with this, I conclude and I open it for any question.
Hello.
Yeah. Yes,
What
Mr.
about data services? How the lawful interception of data services will be going in call related?
So basically,
Call related.
when I say call content, I'm talking about both. So in case of a 5G, even your voice is a data. Even your
Yes.
voice is going in form of a data, and UPF is a point where in a PDU session, it can be data, it can be voice, it can be video, it can be anything. So all are getting intercepted at the PDU session. So I'm able to intercept everything.
Now, what about the encryption part? How the encryption part will play into this?
Okay, so there are two kind of encryption which you will have in the 5G network. One is the network provided encryption. So that means whenever there is a control signaling happening between say your device and the radio, those will be kind of encrypted. So integrity protection and also the ciphering both will happen. Similarly, for the user data also, some encryption may happen. Since these encryptions are being done within the network, so network will be able to decrypt. So agencies would get a information which is decrypted. They'll be able to read the data or listen to the voice or see the video as it is.
Yes.
So
App-based
those are
encryption
fine.
also can be decoded.
No, so like those applications which are kind of OTT, over the top, that means WhatsApp like application. So WhatsApp is like end-to-end encryption, which is nothing to do with the internet facility provider. So whether it's a wireless, wireline, or any broadband, it's an end-to-end encryption which is happening in your device itself. So if such WhatsApp information is sort of encrypted, end-to-end encrypted, so agencies will not be able to decrypt. So whatever information we are able to provide from the telecom network becomes sort of garbage for agencies. So whenever there is a OTT service and there is an end-to-end encryption from the user device itself, we will not be able to decrypt. Agencies are not able to decrypt that, but they will know which number, from which number to which number. All those metadata would be there, but not the content itself.
Internal.
Content
Okay.
is encrypted. So that's a challenge which agencies are having for in case of a OTT over the top applications. Unless WhatsApp shares some detail, agencies are not able to decrypt that.
Thank you.
Thank you. Any other question which you may have?
Sir, can I ask one question, sir?
Yeah.
Yeah, with respect to 2G, we have a SMSC center, that is a separate pathway for handling the SMS. When it comes to UMTS 3G, we have a MMSC center as part of IP multimedia subsystem. So where are these components had gone if you compare with respect to 4G and 5G? Now, in other words, as you said, everything is now in the form of so-called IP based all IP. So handling voice call over IP is fine. What happened to this kind of SMS and MMS in terms of
Okay, great. Good question. So there is one network function which is called SMS function. So there is a separate box for catering to the SMS service. So that is called SMS function in 5G network. So that takes care of SMS requirement. Although when we go through the architecture, we don't show you all the network function of 5G. For example, I had given a list later on after going through part 1 of core and part 2. I gave you a complete list of network function up to release 16. So there we have SMS function to take care of SMS. And for multimedia, so IMS, so now all those services, so has moved out of the network. So earlier services used to be part of the network. Now we have moved out the services as a data network outside the network. So our 5G network is a pure data network. For voice, you have a IMS, voice, video, etc. Native voice, native video would be handled at the IMS level. Those SIP protocols you may be aware of. And then suppose you have any other service. So those are other service providers who have a separate data network which connects to the 5G through those network exposure function. It connects to the 5G network and provide the service. So we have a separate services kind of entities, not part of the network. One example is location-based services. Can be a
Yes,
third-party service which can connect to 5G network through NEF.
okay, sir. Thank you.
Yeah. Any more question? Okay. Okay, so now I open the floor for any other kind of queries, maybe related to quizzes, maybe related to any other point in the ongoing course. Any request which you may have. Okay, if there appears to be no queries or questions. So maybe may I request Madhukar to conclude?
Yes, sir. So it is always great and memorable to listen to Shri Ashok Kumar, sir. Needless to say that your captivating and engaging presentation on any subject marks your command and grasp on the subject matter. The subject of lawful interception and monitoring in 5G is very interesting and exciting to all the participants. Today's presentation would be one of the most exciting and contemporary session in this FBP. Your ability to explain this intricate mechanism of lawful interception and monitoring in 5G in this rapidly evolving 5G technology was truly impressive and provided us a comprehensive understanding of the subject matter and technical aspect of the subject matter. Sincere thanks and gratitude to you, sir. Thank you, sir. Thanks to all the participants for investing your valuable time and dedication in this BP session. Your interest and interactive involvement made this session vibrant, live, and successful. Thank you. Thank you all the participants. All regards, Jai Hind.
Thank you, everyone.
Sir.
Thanks. Yeah.
Sir,
Yes.
one small
Yes.
request regarding quiz marks. We have shared us, but not I